Ah. Julien a dit qu'on pouvait commencer. Voilà, bon, petite introduction, comme d'habitude. Pas des masses de choses à dire. Vous êtes venus normalement? Oui, alors je fais l'introduction en français parce qu'on avait mis French Talk et Evgeny ne voulait pas le faire en français, donc je fais la partie française. Et puis après, on passe en anglais. Merde, j'ai oublié de changer le nom, pardon. Hop là, voilà. Et après, on n'a rien vu, on n'a rien vu. Et après, bah, comme d'habitude, on fera notre petit buffet ici, qu'on ira chercher tout à l'heure pour que ce soit bien chaud, les pizzas et tout. Et j'en profite pour remercier nos sponsors qui sont toujours fidèles et qu'on a vus hier soir pour notre dîner annuel et qui ont tous renouvelé leur sponsoring. Donc, ouais, non, alors, tais-toi. Oui, on n'a pas fêté d'anniversaire, tu sais très bien pourquoi. Non, on en discutera plus tard. Donc merci à nos très fidèles sponsors. Osphère, Ortis, alors je vais faire dans l'ordre, Osphère, Ortis, Calice, Ilem qui sont là quand même depuis 7 ans. Et Soprastaria et Serial qui nous ont rejoints après, mais qui sont toujours fidèles année après année. Et je les remercie, c'est grâce à eux qu'on mange bien. Enfin, on mange bien. Si, on mange bien. Nicolas, arrête. On mange très bien. Sinon, si on mangeait pas très bien, il n'y aurait pas Tom à chaque fois.
Ça tombe bien parce qu'il n'est pas là à chaque fois. C'est peut-être pour ça.
Oui. Alors quand il n'est pas là, il y a des restes. Que généralement, Alban ramène chez lui. Mais et au niveau des prochains événements, comme j'avais dit l'autre fois, alors j'aime bien faire la promotion des autres groupes, mais a priori, il n'y en a plus. Ah, alors... oui, je t'avais dit de me prévenir. Donc il y a le blockchain. Ici. Voilà.
On va installer, on va vous montrer comment installer un réseau blockchain, comment configurer et comment faire sa propre currency, son propre token, crypto token. Ça vous intéresse?
C'est sur Meetup, c'est ça?
C'est sur Meetup, exactement.
Ok. Et salut, non vous n'êtes pas en retard, tout va bien, on vient de commencer. Et non, il y a le .NET User Group qui est encore un peu vivant, mais ils n'ont rien de prévu pour le prochain mois, donc je peux rien annoncer. Par contre, j'ai un truc à annoncer quand même, c'est qu'on va refaire un Devox for Kids, normalement le 20 mai. Voilà, c'est un peu court, mais j'ai assez de personnes pour le faire. On verra selon le nombre d'animateurs combien de places on ouvre, et potentiellement il y aura moins de places, ça partira encore plus vite que d'habitude, et puis voilà. Donc soyez prêts si vous voulez inscrire vos enfants. Et moi j'ai terminé en fait. Evgeny. Voilà, parce que vous n'êtes pas venu pour moi non plus quand même. Alors, hop. Et voilà.
Bonsoir à tous. Oh. Merci GenevaJUG qui organise cet événement. Et merci Xavier qui a annoncé cette présentation en français. Mais, mais je suis désolé. Nous continuons en anglais. So, yeah, we're going to talk about Java code coverage. If you don't know, my name is Evgeny Mandrikov. I'm one of developers of JaCoCo library and Eclipse plugin for code coverage EclEmma. We have a guest today, Mark Hoffman, who is a second developer on the BOSS projects. So please welcome. As before, as like in previous year, when you don't come to Devox France comes to you. So this presentation was at Devox France. If recording here won't be good, you just go and watch a recording from Devox France. It will be good. It will be way better than the one at Devox France. Okay. As usual, a little disclaimer in an Oracle style, a huge one that I think what I say, and I say what I think, and my employees have nothing to do with that. They don't own my opinion, even if they want to. And my employees are SonarSource, so you all probably know which product they develop. For the sake of change, let's try to avoid cliché, French word, right? Okay, so let's try to avoid cliché and let's start from the questions. More seriously, questions from me. Who is there to learn more about code coverage, about how to write tests, how to measure code coverage? No one? No? No? Okay. Okay. Okay, very good. Who is here and already knows how to use JaCoCo library and uses it? Not much. Okay. Who is here to learn more about Java? Okay, a couple of people. Why you came here?
For you.
For food? Yeah, for buffet. Okay. But okay, it's a failed joke. I'm not gonna say that you all should leave the room because you came for nothing. No. We're gonna talk not about code coverage. We are gonna talk not about Java. We are gonna talk about Java code coverage mechanics. So about internals of Java and internals of JVM on example of code coverage, how to compute code coverage. And here is a real disclaimer. Sorry for previous one. The real disclaimer is we are gonna see a blood out of internals of JVM. Sorry for that, be prepared. We're gonna talk strong language. Again, sorry for that, we're gonna talk bytecode, be prepared. And I'm gonna try to do intense violence for your brain. Really sorry about that. If you wanna leave, please leave now. And of course, we are going to talk about implementation details. So dragons are here, be warned, don't try to do clever things at work, the ones that I'm going to show you. A little bit of history behind the JaCoCo project and EclEmma plugin for Eclipse. Initially, back to 2004, there was a pretty nice Emma library. But there was no integration with Eclipse, so thanks to Mark, there was developed an Eclipse plugin, EclEmma. But at some moment of time, it became around 2009, it became obvious that Emma doesn't evolve. So there was a need to develop a new library, and that's how JaCoCo was born. Funny fact, even though Emma is about code coverage, there was no single unit test in this library. Ooh, yeah, and it's still there. It's still sometimes used, surprisingly. But okay, time goes on. At some moment of time, the Java 7 came and Java 8 came, and we did some changes to support Java 8. And if my memory is correct, we released it at the same date as release of Java 8. So we brought a support for Java 8 at the same day as Java 8 release. We will try to do the same with Java 9. Actually, if you take the latest version of JaCoCo, it already works with Java 9. We're going to see which changes were required on our side to do that. Also, on the EclEmma plugin side, we are currently, after 10 years, we finally decided to move this baby into Eclipse Foundation. And main reason for that is you're going to install You're going to install Eclipse Oxygen, next version of Eclipse, and you're going to get code coverage built in without the need to install any plugin. Okay, let's move forward. As we are talking about code coverage, which is a measurement, it's important to remind about such fact as observer effect. So here is a quote from Wikipedia. In few words, any instrumentation alters the state of what you are trying to measure. So all the code coverage measurement is anyway about changing your program in one way or another. And the goal of a good code coverage library is, And the goal of a good code coverage library is to minimize these effects of a change. So basically to have less impact on performance, to not have an impact on thread safety of your application, and so on. And we're going to see how we try to achieve all this. So how do we try to achieve this? There might be various approaches to do instrumentation of the bytecode in JVM. We can try to use some runtime profiling interfaces, but this is not our choice. We try to do in instrumentation of bytecode. One of the ways is to instrument the source code, is to modify source code to do a measurement. Then you need to recompile this source code and you will get a measurement. This is not our preferred way because it complicates the cycle of building your application for measurements. You need to rebuild your sources. We prefer bytecode instrumentation. We can modify bytecode. We provide two ways to do that, either on the fly, either offline. Offline, you have already classes, you can instrument them. On the fly, you have classes, you just run your application with a Java agent, and everything is going to happen automatically. So we work only on class files. We don't work on a bytecode. We don't work on a source code. This is important. We work on a bytecode. We don't work on a source code. So having a class, you can instrument this class. Then you execute it in your JVM. You get some dump of this execution. And then for wrapper generation, you take original classes. You combine them with execution information. We perform some analysis. And only there we have a connection with source code, only to show you the report. On all other stages of the process, source code doesn't play any role. And so, as I said, on-the-fly instrumentation is super easy as just setting an argument for the JVM. So Java minus Java agent, name of a JaCoCo agent, some option to it, and your application. And here we go, and you're going to get execution file at the end. This is possible thanks to the JVM APIs that allows you to write agents, that allows you to add the transformers that gonna kick into the process of loading classes to retransform the bytecode. So little snippet how such transformer, how such agent could look like. In order to bring you this compatibility with a wider range of JVMs, with upcoming Java 9 and so on, we have a big validation test suite. We check many various control flows and we assert how code coverage should look like in such cases. Here are some examples of those validation test suites. We test on, as I said, on many various JDK versions. And thanks to this, thanks to validation test suites and on testing on a wide range of JVMs, we find issues not only in JaCoCo. We find issues also in OpenJDK. So there is even a special tag, as you can see here, there is a special tag JaCoCo found. So some of them are resolved, some of them are still open and planned to be resolved and so on. Some of them, as you can see, quite scaring, JVM crash. Some of them is, something about thread safety. I can make you one promise. We are going to find at least 2 bugs in JVM during this talk without even writing any code. So, and apparently after all this, we are in top 5 of contributors in top 5 of bug reports to OpenJDK among such projects as Apache Tomcat, IntelliJ IDEA, and so on. But okay, close to the main subject. How do we do code coverage? In order to measure what was executed in your application, we are inserting in a certain position so-called props that when probe is executed, we know that some part of a code was executed. So let's have a look on the places where we need to insert probes. One of such places is the end of a method. If just before the return from a method we are going to insert probes, then we will know for sure that we reached this endpoint. Pretty simple. Another one, if in a bytecode we have unconditional jump to some other bytecode instructions, then we can insert probe just before this jump. And if the probe is executed, we know the jump happened, and actually we know everything what was before this goto, what reaches this goto, also was executed. Another one is a bit more complex. If we have a conditional jump, then we need to determine which edge of this jump was taken. So what we do, for internal simplicity, we're not going to go deep into this. We invert the condition and we insert probe if inverted condition is true. And this tells us information whether initial condition was true. Then, pretty simple last case, if we have just some sequence of instructions, somewhere in the middle we can insert probe, and this probe is going to tell us that sequence above the probe was executed. Given those 4 simple cases, almost all of them simple, combining them in a different ways, this is enough to measure execution of any complex control flow in JVM. We are not going to go deep into how to combine them for various control flows. We can take questions afterwards. But I hope basics are pretty clear. Okay. So, as was said, we want to speed for your application. We don't want to affect you by insertion of heavy probes that take a lot of execution out of, that take a lot of time to be executed. So we have some requirements for an actual code of probe. It should have a minimal runtime overhead. It should be fast as possible. It should have no side effects on application code. If because of us your application will crash, it won't be really good. You will come back to us and say, what the fuck? It should be thread safe. If we insert code that is not thread safe, we might turn your application that was fully thread safe into something that is not thread safe. And you will be wondering why your test started to fail or whatever. And yeah, obviously, we inserting those probes to record the fact that they were executed. Also, from the probes, we want identification. So we want to come back from a fact of execution of something. We want to be able to come back and understand what was executed. So they should be identifiable. We should be able to recognize, okay, this is one probe and it was there, another one was there, actually. And apparently, the minimalistic code and minimalistic super simple and respecting all those requirements looks like this. We have an array of booleans. Into some position of this array, we set value true when probe was executed. Let's try to make a quick quiz. Why this is thread safe? People, I want to make intense violence of your brain. I need to warm you up. This is just a warm up. This is supposed to be super simple. Array assignment is thread safe. Why? This is an easy one. Yeah. It's atomic. It's atomic. It's a single instruction. We are not reading value. We are just writing. It doesn't matter if multiple threads will write simultaneously something into it, because they're going to write only true into it. So the final value, even if they concurrent somehow, the final value will be true. Okay. Yeah. If we go to the bytecode level, the writing of true into Boolean array takes from from 4 to 7 bytes. So it's pretty small. At the Vox France, there was a nice dispute whether it can be smaller or not. We are not going to go into this dispute. We do believe that it's pretty hard to have a smaller bytecode sequence that is going to satisfy the same requirements. Quickly, here is how it looks. Allowed, we load onto the stack, onto the JVM stack, the array of probes. Then we push onto the stack the identifier of the number of elements that we want to set to true. Then we push the true onto stack, and then we call instruction that takes 3 last elements of a stack and performs the actual set. But okay, let's move forward. Why we can't? Okay, so thread safe was easy. You ready? Okay, let's have a look on the bytecode of assertions. If I will write such a simple application, let's call it application. It has only one class, it has only one method, and this method doesn't assert. Is there anyone who knows how this is going to be translated into the bytecode? No? Okay. Good for you, there is a tool called JavaP that comes with JDK. JavaP is not really a decompiler, but let's call it decompiler. It can show you the actual bytecode of some class. And yeah, so by writing such a command, we simply ask, please give us the bytecode of the compiled class fun. And if you will look into this bytecode, this is excerpt of a bigger piece, and this excerpt corresponds to this method. If you will look into this bytecode, we will find that there is a call of getStatic, there is somehow 2 conditions, then there is a call of constructor of assertion year, and then there is throwing of this exception, and then there is a final return from a method. So even if we don't know the bytecode, we can understand this part, right? Assertion, if assertion fails, it throws assertion error. We can understand probably one of the existence of one of the conditions just because this is a condition. But it's pretty hard to understand a second condition. And it's pretty hard to understand what is assertions disabled. Okay, we can guess that getStatic probably gets a value of some static field. But in our class, there is no such field as assertions disabled. Any explanation of this strange bytecode? Yes, in Java command line, there is an option you can activate or deactivate assertions. Moreover, this option is smarter. This option gives you a control like, let's enable for those classes and don't enable for others. But what's the connection of some static field in this class with some command line option? I haven't declared any field in this class. Okay, let me give you an answer. Apparently, Java compiler, JaVUG, it creates such a field when we do a compilation. It creates some field in your class even if you haven't asked for the creation of this field. And in fact, your simple assert after all Java compiler transformations is going to look like this. There will be indeed 2 conditions, one on the field and another on the actual conditions that you put it into assert. Let's look more precisely on this injected field. First of all, you might see a strange keyword synthetic. This keyword doesn't exist in Java source code, right? Oh, yeah. Okay, right. But synthetic so-called attribute exists in the bytecode. Synthetic attributes denote the constructions that were generated by Java compiler to distinguish them from everything else. So basically, this synthetic says, okay, there is a field, but this field is not presented in original source code. Let's remember this fact. Then answering on the question, why this field is here? The answer is, given that there is a command line option to enable or disable assertions, you need to ask Java virtual machine, could you please tell me for this class, are assertions enabled or not? And if you will be doing this each time when your assertion is executed, you will have some performance hit. You will be going to some massive infrastructure to get the answer on this question. In order to avoid this massive infrastructure, we can ask the question once at the time of initialization of this static final field and remember an answer, and then use only the remembered answer. If you will go, this method actually exists, so you can go and check that it's quite massive infrastructure because it involves some security checks, it involves some synchronization, and so on. So all this trick is just to avoid performance overhead. Quite a nice trick, isn't it? Let's use it for our nice, it's a pretty nice idea. Let's use it for our nice code coverage library. So what we are doing at JaCoCo, actually, we are creating another synthetic field. Why synthetic? To denote the construction that doesn't exist in source code. We're going to initialize it. We are going to ask massive infrastructure of JaCoCo runtime. Please give us the array of props that we will be using for this class. And we will store it in this static final field so that access to a props of this class is super fast. We don't need to go to the runtime again. And again, this avoids massive checks like synchronization and so on. Because array is already here, we don't need to do anything additional. Nice, isn't it? No? You, Nicola, tired? You need to warm up. Okay. Nice idea. Let's have a look on the following. No, not let's have a look. Another quiz to warm up here. So you've just learned that there is a synthetic constructions in a bytecode. Do you know? And you've seen one example of such a synthetic construction. Do you know other examples of synthetic constructions? Yeah, you, Nicola, you know. You, Mark, you also know. Someone else. You can write this in your source code. You cannot do it. Okay. Probably. Okay. I don't know.
I was wondering.
For serial version UID, I really don't know. Maybe you're right. Something else? Someone says bridge methods. What is that? For generics. What is that? Oh, sorry. Okay, bridge methods, not an example of generics, but on some other examples. Imagine that you have an outer class and you have an inner class. And in outer class, you have a private field. And an inner class does an access to a field of an outer class, to a private field of an outer class. Doesn't ring the bell? No? Okay. Bridge methods. For such a code, if you will look into the bytecode, again using our Java P that we learned, first of all, we might notice that after compilation of this, indeed, we are going to get two classes, outer and outer inner. If we decompile them, we might see something that is not presented in our source code. In the inner, we will see a field with the name this. In an outer, we will see a method with a strange name access. We might wonder why, and the answer is While from a Java language specification, from a source code point of view, it's perfectly valid to access a private field if you are an inner class in the same file. But from a Java virtual machine specification, it's invalid. Those classes are two different classes within the same package. And two different classes within the same package, they can't access privates of each other. To overcome this trick, Java compiler generates a method that is not private, that is perfectly public, through which an inner class is going to do his operation on a private method of an outer. This is another nice trick. This might look hard already, but be prepared for more. Also, this might look like a security issue, actually, because now, if we know the name of this method, then we can actually easily access the privates, just being in the same package. And if I'm not mistaken, they plan to fix this in Java 10. They plan to finally align Java virtual machine specification with the Java language specification to get rid of this mess. Do you have some other examples of synthetics? Here is a hint. Maybe. There is some methods, and Xavier can't remember. Are you a Java developer? Yeah? Ah, you don't use enums. Okay.
He has been stuck at Java 4.
Okay. Okay, in enums there are method values and value of. And this is a common misbelief. They are not synthetic. Sorry, Xavier, but they are not synthetic. There is those two methods. They are generated by compiler. Why the hell they are not marked as synthetics? You can invoke them from the source code. Why not? They exist in a bytecode. I will tell you more. On the previous example, you can actually, from the source code, you can actually invoke this bridge method. As long as you know the name of the bridge method. Sorry? Why we don't generate them if they're not part? Of the language specification. Okay. Maybe. I know another explanation, and the other explanation is while you can write source code to call them, IDE doesn't show you synthetic members. So you can write a name of synthetic member, but IDE will never autocomplete you the name, because IDE skips synthetics members. You don't want to access them. While for those two methods, you want an IDE to help you and autocomplete them. No, I say I think I know one of the explanations. Okay, cool. Remy Forex was agree with me. But now we know another explanation. So the answer of Mark is that Java compiler doesn't look into synthetic methods. Okay. Okay. Sorry? Lookup is not done on synthetic methods. Okay. Sorry, spoilers. Some other examples? It's just to help you, come on. You're almost sleeping. There was 1 second spoiler, now there should be an immediate answer. Your famous, most favorite feature of today. No. Alban, you are fan of this feature. Yeah, okay, lambdas. If you will take such a simple code that uses lambda, that has a lambda here, runnable functional interface, if you will compile such a code, no matter what's inside of a lambda, and we will decompile it using our command line tools that we learned, here you might learn that you can pass various arguments to it. -l is argument that tells, please show us also line numbers. And if you will look into decompiled code, you will notice one more synthetic member, which is a method whose name starts with a lambda, and whose body, line numbers of this body will be exactly corresponding to the line numbers of this code. So basically, lambdas, they got compiled into a special synthetic method. This is pure implementation details. Once again, this might change at some moment of time. So dragons are here. But OK, enough with some examples of synthetic constructions. Hopefully, you're not sleeping, Nicola. How we manipulate with a bytecode from a Java code? Thankfully, there is a nice library called ISM. Funny fact about this ISM library compared to Java P decompilers that we've just seen. If you will take a latest JDK, JDK 9 early access, if you will use it to compile some source code, and we will try to use this ISM library on the compiled bytecode, we will get illegal argument exception. Why? Because ISM library needs to be updated to read the new class files produced of JDK 9. Pretty logical. Pretty logical that maybe we will not get release of this library before the release of the JDK, because specification is not frozen, so chicken and egg problem. And we need to solve this problem for our beautiful JaCoCo library, because we want a compatibility with JDK 9, and we want a release at the day of release of JDK 9. So, yeah, remembering our Java P, and here is a funny fact. If we will take a pretty old Java P from the previous JDK, this Java P will successfully decompile the bytecode that was compiled for Java 9. As long as this bytecode doesn't use constructions introduced in Java 9. But ISM library can't. ISM library throws illegal argument exception. Another interesting fact, a hidden treasure of JVM. You will not find this in any documentation. You can use a special hidden option -x details, -xd details, and the decompiler is gonna annotate next to the bytecode. It's gonna show a source code, so you can see them side by side. But okay, coming back to ISM, how to solve the problem of illegal argument exception? We use a nice trick. We check if given class bytes correspond to a version 9 of bytecode. If they do correspond, then we wanna change couple of bits in those bytes to make ISM library believe that this is actually Java 8 bytecode. Then we do all the transformations. Then we do all the transformations that we want, and we upgrade a couple of bits back, so that outside, no one is gonna notice that we did this trick. Input is Java 9, output is Java 9. All good. And no need to laugh. This trick works just because in Java 9 there is no new bytecode instruction. The only thing that was added in Java 9 is some constant pool attributes for the modulus, for the reading of module descriptors, for the reading of something from Jigsaw project. And our code coverage library will never face reading of such files. So we will always be reading something that contains a pretty good old known bytecode. Yes. The semantics of JVM, previously it was possible to have privates into interfaces. Anyway, they wouldn't be executed by JVM, but in bytecode you can have them. So indeed, yeah, not allowed. But now it's allowed. Yeah, now it's allowed. So yeah, basically the bytecode stays the same, JVM evolves. And yeah, this change of a major bytecode version, it denotes a reval of JigSaw to describe that, hey, we also have a model descriptors and to denote the changed semantics. So that indeed JVM can understand, okay, now we have this version, we can allow new semantic and so on. So this is almost the only one trick that we needed to do for support of Java 9. Easy. Easy. Yeah. Okay. So, yeah.
How did you find this CDK? Really the bytecode of the Java?
Yeah, obviously you can find it into the source code of JavaP because OpenJDK project is open. If you read thousands of classes, you will find it somewhere, yeah. Another way is to read thousands of items in the bug tracker and find the one that describes, let's introduce this hidden option. And in fact, I did the second way. I was searching for a particular bug in the bug tracker and came across this one. Probably the implementer of this feature already forgot that this feature exists. But okay, if this was easy and you warm it up, it's time to enjoy some hardcore. Okay. So, let's say we have a child. Within this child, we have some method. Within this method, we have our friend assert. This time, not X to simplify work for your brain. We have 1 equal to 2, simple math. And as it is a child, it should have some parent. So we have some base class that extends. So child extends base. Here is a base. Base has a static initializer. And for some reasons in our static initializer, we want to create an instance of a child and call on it some method. Now your brain starts working, okay. So the question is, if we're going to execute this and create an instance of a child, what is going to happen? Mark, I know you know the answer. But guys, simple math, 1 equal to 2. Depending, okay, what are the options? Doesn't compile. Sanity check pass it. I verified all the examples that I show, they do compile.
So basically you load the class child. So that means that you have to load the class base.
Okay.
So that means that at that point the static block must be executed.
Okay. Or not.
Not.
Why?
If I remember well, it must be, but I mean, since
Okay.
you are showing that.
So
Then you call the constructor.
there is implicit constructor. Okay, you call a constructor.
Some method, and then it breaks because of the assertion. If it's
Assertion error.
yeah, if it's enabled.
If it's enabled, it's assertion error. Unfortunately, it could be. This is going to be successfully executed, and Nikolai is actually right. If assertions enabled, then we will logically get an assertion error. Okay. What if assertions disabled? Pretty logical, but unfortunately wrong. That's the trap. Do I have a slide? No. If we will recall how assertion looks like in a bytecode level, we will remember that there is in class where assertion is present, there is a synthetic static final field that whose name, by the way, assertions disabled, and which says whether assertions disabled or not. In order to decide whether this assertion is disabled or not, we need to look into this field. What is going to happen in this example? During initialization of a child, we need to initialize base. During initialization of base, we need to call static initializer. During a call of a static initializer, we will create a child and call some method. We are already part of initialization for the child. And we haven't yet finished initialization of a child. So all that unfinished work in initialization of child is still unfinished. In particular, initialization of a static fields in a child. So we haven't yet asked for an actual status of assertions. And the field is assertions disabled, and it has a Boolean type. So for Booleans, we know the default value is false. So here we will believe that assertions, even if they are disabled, we will believe that they are enabled. And this is going to give us, again, assertion error. And here we complete our promise. This problem belongs to one of the recently created bugs in OpenJDK bug tracker. Easy, isn't it? Okay, but Nicola woke up finally, so we can continue with the harder cases. So this problem, we call it bad cycle. And why is this bad? If you will look again on our JaCoCo library, we use it the same trick, exactly the same trick with static final initialization. And if you will be on the same, exactly the same bad cycle, we will get a null pointer exception, because for the arrays, the default value when it's not yet initialized is null. So we might have a null pointer exception. So let's try to solve this problem for our library. Should be noted that, in fact, while this happens on practice, and there is actually another opened bug for another coverage library, Cobertura, so people do write code like that. They have a calls of a child from the base classes. Please don't do this. This leads even to some problems with locking on a class loading. So please don't do this. But people do, so we need to protect from this null pointer exception, and so we need to make some fix. And here is our solution. Here is our fix. We introduce another synthetic member, which is method. This method is going to have a simple code. If field not yet initialized, so if it has a null value, then let's initialize it. If it is initialized, then let's return the value that is there. And instead of going through the field, we will be going through this initialization method. Now, looking on this, you might get an answer why JaCoCo injects two synthetic members. This is a common problem for integration of JaCoCo, because code that uses a reflection but doesn't ignore synthetics, it's going to see those two members. So when you use reflection, please ignore synthetics. Okay? And this is our solution. Please relax on it a little bit. Please look carefully on this. Do you see any problem here?
You will have to call the method every time, which adds to the...
Yeah, fair argument, which might add some overhead. Let's believe in JVM, and let's hope that method is going to be inlined and branch is going to be predicted. We can do the measurement, but let's believe. But also we might say that, okay, we are going to get a hit on performance, but what are the alternatives? Null pointer exception.
Or good coding practice.
Or yeah.
Make a direct call to a synthetic
We generate bytecode. In a bytecode, we can generate whatever we want. So we generate a call to the synthetic method. Yeah, here we explicitly insert the call. We want to do this call, so we modify bytecode in the way to invoke this method. That's fine. Why it is not thread safe anymore? You check for null before assigning. With what? With apparently the same value that this runtime is going to give for the same class. Yeah, that's a way more close. Thread safety, yeah, we can think harder, but I don't see the thread safety issue here. Remember this thought. Remember this thought. We are still discussing thread safety issue. If it is, yeah, okay, let's move. Nicole Evans, let's move. It is final. Yeah, it is final. In the source code, you can't write to the final. That's true. But apparently, in a bytecode, you can. If we will read what Java virtual machine specification thinks about this, then indeed we go to the put static instruction that writes into the field. We extract from a big paragraph some interesting part, and interesting part is, if field is final, then instruction that the put static instruction that writes to this field must occur in CLInit method, otherwise an illegal access error happens. So to the static final, you can write only from a static initializer. And here we are writing from some method. This is not supposed to work. But even though it's written in Java virtual machine specification, it was not checked for many years. It was perfectly valid to do this. And we did this. It worked till recent days. It started to fail in JDK 9. And only for some certain class files, because they finally decided to check this condition. Why they finally decided to check this condition? Because they want to do some optimizations on final fields.
Why did
Yes.
you use it in the first place? Because it's wrong, obviously.
Mark, how you invented this? Probably we just overlooked it that it was final. Probably we wrote a unit test passed, probably we wrote a verification test passed. We executed on many applications and our library works.
Okay, so you never checked the specifications first?
Do you check Java virtual machine specification on a daily basis?
No, it's like using unsafe. Something tells me that it's wrong to use unsafe.
I do remember some parts of Java virtual machine specification, but not all of the pages.
Probably you make the same mistake every day, because you're probably not writing bytecode, but you're writing source code.
Probably.
So you're writing source code. So when do you think is your source code okay?
When I look at it and it compiles. And
It compiles, but compiler might have a bug. It's not a black magic. It's not a black magic. In Java 8, they did some improvements on type inference, and apparently they got it wrong in respect to the specification. But okay, let's move a little bit forward. We all do mistake. We shouldn't blame nor us nor OpenJDK. It happened. It happened. Let's fix this problem first. And
and it was about the probes, how you insert probes. And if you remember, the
it's inverted.
And at the very beginning, I checked the specification, what can I do, especially in the case of constructors. And the specification does not allow, does not allow to jump reverse or jump backwards within a constructor. So there must not be a go-to which goes backwards in the constructor, as long as the superclass is not initialized. And
but I think on practice this is possible.
yeah, in practice it's possible. And this is basically this was an error specification that at least
So there is errors on both sides. Okay, let's move forward. So how we're going to solve the problem? We're going to get rid of final. Easy like that, right? That's what we did. That's what we did. What about interfaces? It's okay. In interface, even though we need to have all the fields implicitly static final, it's okay. Interfaces, they do not have any executable code, so we will never insert any props into interfaces.
Any executable code?
Yeah. There is no interfaces are about declaring interface. They are not executing. Yeah, until the default methods, right? You woke up. You really woke up. You are listening now.
I see that.
Oops.
Me,
Yeah.
so,
Yeah, oops. Default methods. Yes. So, what's the problem? The problem is in interfaces everything should be static final. But we want to get rid of a final on our magical field, right?
even in the bytecode?
So, yeah, so you are thinking correctly. First, we need to check if we do have a problem that we were trying to solve with this method. If we can have a bad cycle initialization problem, but with interfaces. If with interfaces we can't have such a problem, then we don't need a method. If we don't need a method, then we don't need a put static from a method. We can put static from static initializer. No problem, no need to add complexity. So let's try to write such an example that will show whether we have a problem with interfaces, whether we don't. And this time, Nicola, yeah, after your comment, this time we are going to first read the specification and then write some code. Yeah, thank you very much. So if we go to this time to the second Bible, not to the... no. Sorry, let me check. Yeah, to the second Bible. First time it was Java virtual machine specification. This time we are going to the second Bible, Java language specification. What Java language specification says? When initialization occurs, all this bad cycle problem is about problem of initialization. So classes or an interface will be initialized immediately before blah blah blah. Instance of the class or is created. Static method declared by a class is invoked. Simple. Instance created of a class, initialization. Static method invoked, initialization. Okay, let's move. When class is initialized, we need to initialize any super interface that declares any default method. So above we describe when class initialized, below we say that also if we initialize a class, we need to initialize all the super interfaces with default methods. Simple. Without all the water of Java language specification. Yeah? Do we need to explain this more? No? Okay. Let's try. So let's try to write bad cycle with interfaces. We need to trigger initialization. We need to trigger initialization on interfaces. So in order to trigger initialization on interfaces, we will have some class. In this case, an anonymous class implementing the interface child. Or we might call a static method on this interface. And again, we can do that. Let's write an interface. As before, for bad cycles, we need some base. And we know that in this base we want to call a method on a child. So let's call a method on a child within a static initializer of this interface. Also, what we read just before says that to trigger initialization in a base interface of this class, we need to have a default method. Let's add a default method. Now let's have a child. For bad cycles, we want it to extend base. We want a default method to be able to call it from the base. And just two little things. We print at the time when initialization of child happens, and we throw an exception just to see the stack trace at which moment this method was invoked. Just to see what was before within execution sequence. Simple. No? Not that simple as before. I agree. But, again, just to prove our theory or disprove it, we want to prove whether there will be the same problem as before, so that we wanna see the order of initialization. We wanna see whether child is gonna be initialized before base or after. So, as per specification, we inject default method to trigger initialization of base. As per previous example, in a base we call method from a child. In a child we extend base. We have the method, and that's it. Can have attributes. It's static final field. Yeah. It is implicitly static final, and interfaces do have. We can write here static final, and IntelliJ will tell us static final is redundant. Sanity check passed. This compiles. This at least compiles. Okay. Now the question: what's gonna happen if we execute this? Okay, simpler question. What are the options?
It works or it doesn't.
Cool. What? You're right. What means it works? What? It prints something and throws an exception. Acceptable. But okay, you again forgot what we want to verify. We want to verify an order. So we want to know whether it will print before throwing an exception. Or it first will throw and then will never print. We want to determine the order. So there are at least two orders, two possible outcomes. It's either one order, either another. And Nicola gave us another option. Either it works, either it doesn't. What means it doesn't? Yeah. If it doesn't print, it doesn't throw exception, and it doesn't print. What the state is it? Looping, JVM crash. Okay, a lot of variants. Let's do a vote. Who thinks that it's gonna crash JVM? Mark thinks it's gonna crash JVM. Okay, 3 votes for crash JVM. Who thinks that base is gonna be initialized before the child? I can give you a coin, you will flip it. Okay. One for base before child. Who is for child before base? 1 for that. Others? There are no other options.
Yeah, we are Swiss.
Just an exception.
Okay. All others, in fact, are right. In practice, answer is it depends. If we will take a JDK before JDK 8 update 40, the order is going to be like this. First base, then child method, then child initializer. Exactly the order that shows bad cycle problem, but with interfaces. If we will take after update 40, we will get a good order. So apparently what happened during implementation of initialization, developers of OpenJDK incorrectly interpreted some chapters of Java language and virtual machine specification and got order wrong. And then they made a fix. Okay, fine. If we will go further, we will see that also after update 40, it actually crashes because of an exception thrown. It crashes. Order is correct, but it crashes. If we will go further and we will try to do a static initialization by calling a static method, we will see that even after update 40, they didn't get an order right. So, shit happens, Nicola.
Yeah, I know.
Not everybody perfect. And this one was really quite funny because in parallel with Mark, we were writing tests on different machines and we were getting different results. And for me, it was even more surprising because at home I wrote a test, I executed it, I came at work, executed exactly the same test and got another result. What the fuck? Yeah. Yeah, I got a crash. Mark got a crash, I got a difference of orders. Then we bisected all the OpenJDK, found where bug comes from, reported it back, and finally, in update 152 early access, they fixed all this. So we are waiting for that. It's not yet released, but finally it's going to be fixed. But unfortunately, as the order was not right here and here, unfortunately, we already have some JDKs where we have bad cycle problem with interfaces. So maybe someone already uses a code like this. And if we don't put a protection into our JaCoCo library against this bad cycle problem, such a people gonna get a null pointer exception. And they will not go as deep as we are. They are not gonna go into OpenJDK and blame that it's a failure of OpenJDK. It's failure of JaCoCo. Why? Because we take our application without JaCoCo, we execute on JDK, it works. We take a JaCoCo, we execute, it throws null pointer exception. Where is the problem? Obvious difference is JaCoCo, problem is in JaCoCo.
True. I would say again that the problem lies in the original codes, because if they use SonarSource, I would say.
Okay, then, but not everybody use, unfortunately, not everybody use SonarCube. But okay, so we need to solve this, and okay, fine. Final solution is that we're gonna, for interfaces, we're gonna have final. We have no choice. And for interfaces, instead of storing an instance into this field, we're gonna just ask current time and return the instance. If it is already initialized, we are gonna return the initialized value. Indeed, Nicola, you might say that there is a performance hit. And there will be a performance hit on the path when interface is not fully initialized. So hopefully a short fraction of a time till full initialization happens. That's our fix. And this, I think, one of the fixes that also was necessary to do on Java 9 for JDK 9, because the same problem was observed on JDK 9. Now relax. This was the most hardcore part. You went through it. Look at this picture, relax, brace. This is a class loader's hell. Why? Because given ability to create a custom class loaders, you might do very smart things. You might give access to some classes to one class loader. You can remove access to some classes from other classes. You can even load the class with the same name into different class loaders multiple times with a different bytecode. Name is the same, behavior is different, bytecode is different. So, for our code coverage library, if we have two classes, if their names are equal, are they the same? And we need to answer on this question because otherwise, how we will create for you a report? We just don't know against which class to create such a report. So let's first answer on this simple question. If class getName is equal to another class getName, are classes the same? No, because of class loaders. It can be two classes from different class loaders. So for our library, we need a class identification. And what we do, and again, dragons are here, it's pure implementation details. We take a checksum, CRC64, of class bytes of some class, and we get a class ID. And this class ID we use to identify which class contributes which coverage. And this is, again, a common problem in usage of JaCoCo. That's why exactly the same classes you need to supply for a report generation. Because at the time of report generation, we're again going to get class bytes. We're going to generate this control checksum, and we're going to decide, can we create a report for a given class for a given execution data, or we can't. If they don't match, then we can't give you a guarantee that it's the same class. We can't create the report. It might be another class. Maybe you have, in your GBoss server, you have two versions of the same application. So same class names, but different classes. That's why we need original class bytes. Let's move forward on another trick with class loaders. So again, as was said, we can restrict access. We can have restrictive class loader, which gives an access to one namespace to another, but forbids to everything else. Do we need to dig deeper? Simple like that. We can access everything from Java, something from SonarSource, but nothing else. How the hell we are going to access our JaCoCo runtime that is not in a Java package, that is in JaCoCo package? Given such a class loader, we can't access JaCoCo package. That's one of the problems that we finally need to solve. What to put in this magical initializer that we were implementing through all the bugs of JVM last 20 minutes? You're hacking the JDK. Kind of. So, the solution. The solution. Thankfully, we have a transformation engine at our hands that kicks in at a JVM startup and that can take some classes and transform them. So what we basically do, we take a class within a Java package and we inject a field into it, a field that doesn't exist. And now, probably none of class loaders never ever restricts access to Java package. It will be a mistake because Java is a core of platform. You have Java lang integer and so on. So then
At the very beginning, we found a nice use case for Java lang void.
yeah. There was 3, I think, iterations on the different candidates for this. And please hold explanation why we choose this. It will be a quiz. Yeah. So we choose to use this. We inject some field which now every class loader can access, and almost the end of the story. To this accessor, we need to pass what? We need to pass, we want to request a prop array. We want to tell, here is our class ID that we computed, checksum of it, here is our class name, and we want to, for this class, we want this amount of props to be allocated. This is an argument that we want to pass to the runtime, and runtime should return us the Boolean array. Easy. How are we going to do this? there is no interface in Java lang that is going to provide us, that is going to take long string and integer and return a Boolean array. We can search thousands of classes in JDK, but probably we will not find interface saying, I take a long, I take a string, I take an integer, and return Boolean array. JDK developers haven't thought about us, so haven't made an interface for us, unfortunately. The trick is there is equals method. In equals method, we can pass any object. In particular, we can pass an array of objects. Okay? So the receiver on the other side, so JaCoCo runtime, implements the equals method, waiting it to be called with those arguments. Absolutely against any specification, because equals specifies the contract that equals method should obey. But again, we have no choice. To cross boundaries of class loaders, we need some interface. So we choose to use equals. Simple quiz. We need to return Boolean array. Equals returns a Boolean, not an array. How are we going to get Boolean array? Don't sleep, don't sleep. We want a Boolean array to be result of a call which we made. So within this call of equals, we already want to get back a Boolean array. We are? Exactly. Thankfully, arrays in Java are mutable. So thankfully, passing an array into some method, we can get a response back into some of elements of this array. And that's what we do. We're going to change a first element of this array so that here we can read it back. Again, dragons are here. This is implementation details. This might change. No need to rely on this. I've never told you that in Java util UUID there is a new field. There is no new field. Okay. Yeah. Promised quiz. Why we had multiple iterations to choose the class into which inject a field? Why some candidates are good, some are not? No, equals is implemented on the object that is stored in this field. And no one except us is going to access this field because no one knows. Why some classes are good, some classes are not? Serializable what? No. Because of the loading order, our Java agent is written in Java. To run some Java code, you need to load some Java code. So some classes are going to be loaded before our Java agent is loaded. And unfortunately, you can't do a class retransformation. Addition of a field is a class retransformation. Unfortunately, you can't retransform already loaded classes. As of today, no, not as of today. Java JDK 6. JDK 6 allows class retransformation, but we also need to work with JDK 5. JDK 5 doesn't allow class retransformation, so already loaded classes, we can't modify them. Members, even during, indeed, even during retransformation, you can't add members. there is an open JEP Java enhancement proposal to make this possible. Yeah, so you can't add members. So if class gets loaded, so we were taking some like Java lang void as one of the candidates. It turned out that Java lang void is used so early on initialization sequence so that it's loaded before we can inject something. And so on. There were at least one more candidate. I don't remember the name, but there was some other class. And it turned out for some other class, it also was used early on initialization sequence of application servers like Tomcat. If, because of the fact that this information was shared with you, if tomorrow Java util UUID is going to be used at a startup sequence, we will need to pick another member of Java package. That's mainly it. I hope you had fun. So you can get more by Got Involved. So try the JDK 9 to see if you can find bugs there. It's still possible to report them. It's not too late. Feel free to join our forum to answer some easy questions, far easier than the ones you saw here. Now you are far more advanced than any average user of JaCoCo. So join and answer questions. Same on Stack Overflow. Feel free to contribute to our repositories. And this is the end. Any questions? Welcome.
Are there other interesting items that we should explore?
Are there
Any other interesting items?
created by us? No. I showed you everything.
That you discover
Created
created by others.
by others.
Is it the JVM full of a lot of that we don't know?
Depends on the edge.
It is full. -6 D detail. It is full of the stuff that is hidden. Da, da, da.
One task, for example, you know, RT-char. So how many main methods do you find in RT-char? It's hundreds of main methods with some really funny and complicated things. If you want to discover some nice aspects of the JDK implementation, just check RT-char for main methods. It's really
For the hidden fields, another code coverage library, Cobertura, also injects a field. Probably for the same reason. Unfortunately, they have problem with bad cycles, but probably for fast access, they inject a field. Some other questions? No single question about power mock? Do you use Power Mac? So no questions. No one uses Power Mac.
Depends.
You use Power Mac.
Yes, you know when you have to do refactoring and you cannot test.
You just go and do refactoring. No.
So you use power mods to create like really a very nice integration test. Then you hack like crazy.
Very nice. So you use a Power Mac, which hacks on a JVM, which breaks.
I don't care what I do. I want to refactor safely, so yes. And then I remove it afterwards, because afterwards my
Okay.
is testable.
If you remove it's okay.
No,
If you
it's
keep
temporary.
if you keep it, it's bad.
No, I always use it
But
in a very temporary way.
do you really test? How to say? What is going to be executed in production? In particular, Power Mock allows you to mock static finals. Java virtual machine specification doesn't allow you to change static finals. Power Mock goes against Java virtual machine specification. You're gonna test something that is not gonna be executed at runtime. You're gonna execute some trick on top of, but I don't care. But I also know why there is no question on that from you, because you also don't use code coverage tools because you believe in mutation testing. Otherwise, you would immediately say, yeah, JaCoCo doesn't work with PowerMock.
Say if you are using PowerMock,
yeah, if you use PowerMock as well. What about PowerMock? About PowerMock is the following. PowerMock bypasses any agent attached to JVM. Any agent. Not just JaCoCo, just any agent. Because what they do, they go on a disk and load a class files from a disk to do class files retransformation from a disk. That's why people have a problem with PowerMock and JaCoCo. But somehow it's not our problem. They go on a disk, not we are. Something else?
Usually you don't read bytecode.
Is it a question? Yeah, usually I don't read bytecode. Apparently for past, I don't know, 4 or 5 weeks, I do read bytecode on a daily basis. On this subject, okay, I don't know, good news or bad news or non-news or you're tired. Why I'm reading bytecode so often? Because we started a big, let's say, project to filter various constructions that compiler generates which doesn't exist in source code. Like, maybe you know, maybe you don't. If you will write try with resources, JaCoCo is gonna tell you there is, I don't know, 8 branches and you covered just 2. When you look on your try with resources, you don't see any branches. So we started a project to filter all the generated bytecode by compiler to give you a report that more closely represents what you wrote in the source. And this requires a lot of bytecode studying. If there is no other questions, thank you.
Donc, je vous donne rendez-vous le 25 mai. Le 30 mai, merci Maxime. Le 30 mai.